Hello everyone, I'm Difei Gao. I'm glad to share with you our research, MIST Multi-modal Iterative Spatial-Temporal Transformer for long-form video question answering. Firstly, I will provide a brief overview of this paper. Our work mainly addresses the unique challenges of question answering tasks when dealing with long-form videos. The first challenge is the efficiency issue. The computational cost of a transformer will increase exponentially over time. Additionally, we need to handle new reasoning abilities, such as multi-event, multi-grand visual concepts reasoning. To address this challenge, we propose a multimodal iterative spatial-temporal transformer. The core idea of this paper is not to consider all the details of the video at once. Instead, it first obtains a general overview of the entire video, and then examines the specific details based on the given question. The model can iteratively examine the video multiple times to answer complex questions. Now I will introduce this paper in detail. First, we believe one of the ultimate goals of video QA is assisting users in their daily life. For example, we require a model to understand an instructional video and use the knowledge in it to guide users in some complex tasks. Or we want the model to understand the user's activities, help users in manage their life. Both application scenarios require the model to process and understand long-form videos. So let's take a look at what existing models are good at. Thanks to many recent constructed large-scale multimodal datasets, which provides rich clips with corresponding descriptions, a lot of excellent works propose vision language transformer with sparse sampling strategy and pre-train their model on it, which can capture the correspondence between the visual appearance and textual description excellently. So they have achieved great performance on short-term video-related tasks. However, when we move from short video understanding towards long-form video understanding, there are some unique challenges. The first one is the efficiency issue. Traditional transformer compute dense self-attention over patches, so the computational cost of the transformer will increase exponentially over time. So mainstream pre-trained transformers typically process only 3 to 8 frames per video. Some recent work have found ways to overcome this limitation. Instead of processing every individual patch, they only perform self-attention on the entire frame or segment, which can reduce computational cost to some extent. However, this kind of approach may result in the loss of critical information. Another unique challenge in long-form video understanding is the requirement of new reasoning abilities for answering more complex or general questions. For example, answering questions like Q1 requires reasoning across multiple events, especially temporal order reasoning. For the question like Q2, the model needs to reasoning over multi-grand visual concepts like object, attribute, and action. For the question like Q3, they need to understand the causality between two events. In brief, the model needs to consider multi-events and multi-grand concepts while reasoning. So the basic idea is that we don't need to consider all the detail at once when reasoning over a long video. We can first take a glance at the whole video and select the most relevant video clips, then watch it carefully to require the information of the details reasons. So more technically, we first extract the segment level feature and perform a cascade segment and region selection, and finally perform a self-attention over high-level information and select the detailed information. In addition, to overcome the challenge for multi-event reasoning, we let our model to iteratively perform this layer to allow multi-event reasoning. Please kindly check the details of our methods in the paper. We evaluate our model on 4 recent proposed challenging datasets for the long-form video QA. These datasets are mainly about daily activities. Each consists videos with an average length of 20 to 40 seconds. Our approach is designed to compatible with a variety of pre-trained vision language transformers, allowing for flexibility in its application. We have tested our methods on 2 pre-trained models all-in-one for video pre-trained model and clip for image language pre-trained model. Our method demonstrated a significant performance boost when compared to previous state-of-the-art techniques. We also conduct some ablation study by designing several alternative solutions for long-form video modeling to replace our proposed ISTA layer. We show that our proposed spatial-temporal attention layer outperforms other methods, and segment selection are the most effective modules in our framework. We also evaluate our methods on efficiency issue. The figure on the left shows that sampling more frames is necessary for long-form video tasks. Thus, the efficiency issue is a crucial consideration in our cases. On the right, we compare G-flops versus accuracy of our model against other long-form video QA methods. It can be seen that the standard transformer over patches is computationally extensive. The frame-based method is lightweight in computation, but its performance is limited. Our method requires only a little extra computation but achieves much better performance. We also visualize some success and failure cases from the next QA datasets. It can be seen that our model can explicitly select video clips and image regions related to the question. We can also find that it's difficult for the model to correctly select the segments and reasons when the questions mainly involve some concepts related to the social emotions. Existing pre-trained models may not well understand that correspondence between the abstract concepts and videos. But we believe after revising or improving the pre-trained models, our methods can achieve better performances. Thanks for watching.